Quarter 4, Quiz 1, Review, Sections 7.1 to 7.3, Solutions. Alright, so for the first set of examples, we are writing these exponential equations in logarithmic form. So remember, when we do this, we're going to have log. We have a base, which is that whole number that becomes our subscript, of 9 is equal to 2. So it's asking you 3 to what power is 9? For 14, we have 17.6 to the power of 0 is equal to 1. So the 17.6 is going to go down as our base, and that 0 and that 1 are going to switch places. So we're going to have log 17.6 of 1 is equal to 0. For 15, we have 2 to the power of negative 1 is equal to 0.25. So 2 is going to go as our base, and that negative 1 and that 0.25 are going to switch places. So we're going to have log 2 of 0.25 is equal to negative 1. For 16, we have 0.5, which is going to be our base, and then our x, and our 0.0625 is going to switch places. So it's log 0.5 of 0.0625 is equal to x. Starting with 17, we're going from log form to exponential form. So this 4 is our base. It's going to stay our base. So it's 4 to what power is the 64? That 3 and that 64 are going to move counterclockwise, and it's going to be 4 to the third power is 64. For 18, we have log 1/5 of 25 is equal to negative 2. So 1/5 to the negative second power is equal to 25. You should always be getting true statements with these when you do them. For 19, we have log 0.99 of 1 is equal to 0. So this is going to be 0.99 to the power of 0 is equal to 1. For 20, we have log e of x is equal to 5. So e to the fifth power is equal to x. For our next one, on to 7.3, for our next question, we're looking at 21. So this is f of x is equal to 5/6 to the power of x, where x is negative 1, 0, 1, 2, and 3. So for the purpose of this question, what your quiz question is going to ask you is to give the inverse of f of x is equal to the 5/6 to the power of x. So in order to do this, you're just taking the log of that 5/6 to the power of x. So your inverse of this is going to give you log, or f to the negative 1 of x, f to the negative 1 of x is equal to log 5/6 of x. So this would be your inverse of this. Just like if we had something like f of x is equal to, let's say, 5 to the power of x. So this inverse of this is going to be f to the negative 1 of x is equal to log 5 is your base, x is your whole sort of number. So this is what your quiz question will pretty much look like. Okay. If we look at our next section, for number 22, we have log 3 of 81 plus log 3 of 9. Remember, with our rules with these, we have addition, so we're going to multiply our 81 and that 9. So it's going to be log 3 of 81 times 9. That 81 times 9 is going to give us log 3 of 729. So this is asking you 3 to what power is 729? Well, the 729 divided by 3. 3 goes into 7 twice with 1 left over. 3 goes into 12 4 times. 3 goes into 9 3 times. So then divide that by 3. 3 goes into 24 8 times. 3 goes into 3 once. Divide the 81 by 3. 3 goes into 8 twice with 2 left over. 3 goes into 21 7 times. Divide the 27 by 3. 27 times 9 is 3. The 9 is also 3 and 3. So 1, 2, 3, 4, 5, 6 times. So 6 would be the exponent on that. That is our answer. For 23, we have log 1/5 of 25 plus log 1/5 of 5. So we're adding these, which means we're going to multiply the 25 and the 5. So log 1/5 of 25 times 5. This is going to give us log 1/5 of 125. So that's 125 to what power is, 1 over 5. 1 over 5 to what power is equal to 125. So we know that in order to get this 1/5 to be a whole number, not a fraction, it's going to have to raise to the negative power. So with that, keep that in mind. This power is going to be a negative number. So the 125 is 5 and 25. The 25 is 5 and 5. So 1, 2, 3. This is going to be negative 3. For 24, we have log 1.2 of 2.16 minus log 1.2 of 1.5. So we're subtracting these two, which means we're going to divide the 2.16 and the 1.5. So we're going to have log 1.2 of 2.16 divided by 1.5. So this is going to give us log 1.2 of 1.44. And that 1.2 to what power is 1.44? Think of this as 12 to what power is 144? It's just 2. For 25, we have log 4 of 256 raised to the second power. Following our rules with this 2 as our exponent is going to come out front to give us 2 times log 4 of 256. So we're going to have to solve that log 4 of 256 first. So 4 to what power is 256? Well, 4 goes into 25 6 times with 1 left over. 4 goes into 16 4 times. The 64 is 4 and 1, carry the 2, 16. The 16 is 4 and 4. So 1, 2, 3, 4. So this is 2 times 4, which is 8. For 26, we have log 7 of 343. So this is 7 to what power is 343? Divide this by 7. 7 goes into 34 4 times with 28. The 34 minus 28 is 6. 7 goes into 63 9 times. So then the 49 is 7 times 7. So that is going to give us 1, 2, 3 sevens. 7 to the third power is 343. For 27, we have 17 to the power of log 17 of 0.73. Whenever we have that base that's raised to the log with the same base, they cancel each other out, and the only thing we have left is that 0.73 for this one. For 28, we have log 27 of 343. So this, again, is 27 to the power of what is 343. So we can divide that 343 by 27, and we don't get anything that is divisible. The 27 doesn't go in to 343 evenly. So what we can do with this is we can go ahead and take the log of 343 divided by log 27. Now, you're not going to have any of these on your quiz, so when you do this, you would need a calculator. You would just do log the 343 divided by log 27. Log 343 divided by log 27 gives us 1.77. Again, you're not going to have any of these on your quiz to where you're going to need a calculator. All the ones on your quiz you do not need a calculator for. For 29, we have log 10 of 0.01. So 10 to the power of what is 0.01? Well, think about it. This 1 is in what place value? The hundredths. So this is the same thing as saying 10 to the power of what is equal to 1 over 100. Turning this 10 into a fraction means that that power is going to be a negative number. And then 10 to the what power is 100? It's 2. So this is going to be negative 2. For 30, we have log 5 of 625. So 5 to what power is 625? Divide the 625 by 5. 5 goes into 6 once with 1 left over. 5 goes into 12 twice with 2 left over. 5 goes into 25 5 times. The 125 is 5 and 25. The 25 is 5 and 5. So 1, 2, 3, 4 is our answer. For our next question, okay, I guess there's no more in there. For our next one, we have to solve these. So 3 to the power of x is equal to 1 over 27. Well, 3 to what power is 1 over 27? Negative 3. For 2, we have 49 to the power of x plus 4 is less than 7 to the power of x over 2. I'm going to turn this into an equal sign and treat it as an equation. So we can solve this by saying that 49 is 7 to what power? It's the same thing as 7 to the second power. You're going to still have the x plus 4 as your power, and the 7 is still going to be raised to the x over 2. So now that your bases are the same, you can cancel them out and just work with the exponents. So the 2 times x plus 4 is equal to x over 2. So we can distribute this 2. We're going to have 2x plus 8 is equal to x over 2. In order to get rid of this 2 in the denominator, we're going to multiply each side by the 2. So this is going to give us 4x plus 16 is equal to x. And then we're just going to solve for x. So subtract the 4x from each side to get your x's on the same side. You're going to have 16 is equal to negative 3x. And then we divide each side by the negative 3. So x is equal to negative 16 over 3. For 5, we have log 4 of x minus 1 is greater than or equal to 3. Again, I'm just turning this into an equation, and then I'm going to work from there. So here our base is the 4. So we want to have 4 to the power of log 4 of x minus 1 is equal to 4 to the third power. So now that our base and our log have the same base, then we can cancel those out. We're going to do 4 to the third power, which is going to give us 64. So we're going to have x minus 1 is equal to 64. We add that 1 to both sides, and we get x is equal to 65. For 6, we have log 2 of x to the power of 1/3 is equal to 5. So we can take this 1/3, bring it out front. We're going to have 1/3 times log 2 of x is equal to 5. We can divide each side by that 1/3 or multiply by its reciprocal to give us log 2 of x is equal to 15. Our base here is the 2, so this is going to be 2 to the power of log 2 of x is equal to 2 to the 15th power. From here, we can cancel out the 2 and the log 2, so it's just going to be x is equal to 2 to the 15th power. 2 to the 15th power is 32,768. For 3, we have 13 to the power of 3x minus x is equal to 91. So I'm going to simplify this by doing the 3x minus x first. So this is 13 to the power of 2x is equal to 91. The 13 to the second power is 169. So it's not going to give us a number that is the same on both sides. So with this, we're going to take the log of both sides. So we're going to do log 13 to the power of 2x is equal to log 91. From here, we can just follow our rules that 2x goes out front. So it's 2x times log 13 is equal to log 91. Get the 2x by itself. We're going to divide each side by log 13. And we're going to have that 2x is equal to log 91 over log 13. From here, we're going to put parentheses around this. We're going to divide each side by 2. So using your calculator, again, you're not going to have a calculator for your quiz, so a question like this wouldn't be on there in your calculator. You're going to do log 91 divided by log 13, hit the enter button, and then divide that answer by 2 to get 0.88. Again, if this was a quiz question, I would expect your answer to look like x is equal to parentheses log 91 over log 13 divided by 2. For our next question, we have 2 to the power of x plus 4 is equal to 20. So 20 can't turn into 2 to the power of something, so we're going to just take the log of both sides. So log 2 of the power of x plus 4 is equal to log 20. We are going to move the x plus 4 out front. So this is going to be x plus 4 times log 2 is equal to log 20. We divide each side by that log 2. So x plus 4 is equal to log 20 divided by log 2. From here, we would subtract 4 from each side. So this can be written as x is equal to parentheses log 20 over log 2 minus 4. If we were using a calculator and were to solve this, we can do log 20 divided by log 2, hit enter, and then subtract 4 from that to give us 0.32. For our next 2 examples, which are our last ones, we have log 16x minus log 4 is equal to 2. So we do have subtraction here. So we are going to divide the 16x and the 4. So we're going to have log 16x divided by 4 is equal to 2. The 16x divided by 4 is 4x. So log 4x is equal to 2. How do you get rid of the log? What's your base on it? Your base is 10, so that's going to have to be the base on both sides. So it's going to be 10 to the power of log 10 of 4x is equal to 10 to the second power. So from here, the 10 and the log 10 cancel. So 4x is equal to 10 to the second power, which is 100. We divide each side by 4 and get that x is 25. For 8, we have log x plus 3 is equal to 1. So we are going to keep the log, and we're going to multiply x times x plus 3. So this is going to give us x squared plus 3x. So log x squared plus 3x is equal to 1. Again, our base here is 10, so we're going to have the base be 10 on both sides. So we're going to rewrite this as 10 to the power of log x squared plus 3x is equal to 10 to the first power. The 10 and the log cancel, so it's just going to leave us with x squared plus 3x is equal to 10 to the first power, which is 10. We want to move that 10 over because we have an x squared, so we're going to factor by grouping. So the 10's cancel out. We're going to have x squared plus 3x minus 10 is equal to 0. Your factors of that negative 10 that add up to be 3. We have a positive 5 and a negative 2, which is going to give us 3. So this is going to factor out to be x plus 5 times x minus 2 is equal to 0. We solve both of these, so x plus 5 is equal to 0, x minus 2 is equal to 0. We get x by itself. Subtract the 5, x is equal to negative 5. Add the 2, x is equal to 2. Now, when you are working with logs, your negative logs, or you can't do work with negative logs, so that negative 5 is not your answer. The only answer that you have is x is equal to 2. So you're only going to be taking the positives of these answers.